Hey guys, today we're starting hyperbolas, which is the second of our conic sections. The first one that we did was ellipses. So a hyperbola is the set of points in a plane, the difference of whose distances from two fixed points called the foci is constant. All right, and I just want to point out that this definition is word for word exactly the same as the definition of an ellipse, other than one word, and that is difference instead of sum. Okay, so the definition of an ellipse was if you took any point on that ellipse, you took the distance to one foci plus the distance to the other. That sum would be the same for every point on the ellipse. Now with a hyperbola, you're subtracting. So the distance to one foci minus the distance to the other will be constant for every point on the hyperbola. Okay, so now standard form of a hyperbola. You'll see that the equation looks very similar to that of an ellipse. Okay, the center is at HK, that's exactly the same. One difference, the major difference that you should notice is that it's subtraction. There's a minus sign in the middle instead of a plus. Okay, so for an ellipse, both the x term and the y term were positive, so we always just put x first. All right, but now one of them's positive, one is negative, so you put the positive one first. So you see it's either x minus h squared over a squared minus the y term, or the reverse, which would be y comes first minus the x term. All right, and the first thing is how you're going to determine whether it's horizontal or vertical is which term is positive. Okay, so on our first one here on the left, x is positive and we're subtracting y. When x is positive, I think x values go right and left. So that equation would be a horizontal hyperbola. And on the right, y comes first, or y is positive and you're subtracting x. So that's a vertical hyperbola. Okay, the next thing is for your foci equation, it's really similar. It's c squared equals, in this case, a squared plus b squared. Okay, so for ellipses, you might remember it was a minus in there. Now it's addition for the foci equation. Okay, and the way that I think of it is ellipses, the standard form equation has a plus in the middle. That foci equation has a minus, c squared equals a squared minus b squared. So it's the opposite. For hyperbolas, your standard form has a minus and your foci equation has the plus. Okay, so the next thing is asymptotes. All right, so you guys should recognize that word from last year. And asymptotes, typically the ones that you dealt with in Algebra 2 were probably either vertical or horizontal. Okay, in the case of a hyperbola, you actually have what are called slant asymptotes that basically form an X that goes through the center point of your hyperbola. That's where they intersect, the two asymptotes, and they help determine the shape of your graph. So once you know where your asymptotes are, those hyperbola curves approach those asymptotes without ever touching them. All right, and now what are the equations for your asymptotes? So your asymptotes, you're going to be asked what are the equation of the two asymptotes. There are two of them, right? And they cross and form that x. And that's reflected by the plus or minus. A plus or minus should tell you that there are two asymptotes. Okay, and you might recognize this formula, y minus k equals m times x minus h, except usually you see it as y minus y1 and x minus x1, and that's called point slope form. So you guys learned that in Algebra 1, point slope form of a line, y minus y1, where y1 is some point on the line, x minus x1, and then m, you should all know m is your slope. Okay, so m represents a slope. And I want to remind you of those two R words for slope, rise over run. Okay, and that's going to help you because when you're determining what the slope is, it comes from your denominators. Okay, so from the a squared and b squared, except you're using a and b. Okay, it's always either a over b or b over a. So square rooting the denominators. All right, and how you decide which is which, okay, is it's going to always, your m or your slope is always going to equal the square root of whatever your y denominator is over the square root of your x denominator, or the denominator under your x term. Okay, and that goes back to rise over run. Remember, rise refers to y values, up and down. Run is right and left. That refers to x values. Okay, and this should make more sense once we actually get into a problem. So right now, pause the video and take any of the notes that you might have missed. All right, and all I've done so far is basically point out how this is slightly different from ellipse equations. All right, guys, so I want to try number 1 here in this video. We're going to do the rest in class tomorrow. So sketch a graph of the hyperbola. The first thing is the center point. Remember, your center is h comma k. Okay, but I want you to be very careful here. H is always what's subtracted from x. Notice on the right here, x didn't come first, y came first. So h is what's subtracted from x. Okay, so one common mistake is here students would say 2 comma negative 1, but make sure it's always the x coordinate of the center first, so negative 1, and then the y coordinate, which was 2. All right, so I'm going to graph that center point now. Next, vertices. Okay, your vertices, you have to determine, is this a horizontal hyperbola or is this a vertical hyperbola? And a little bit different from ellipses. From ellipses, you guys might remember, you would look at the denominator and see which one is bigger. And that's how you tell vertical ellipse or horizontal. For hyperbola, it's which one comes first or which one is positive. So since this is a y term minus an x term, this is a vertical hyperbola. Okay, and you're going to go up and down, similar to what you guys did for ellipses, by the square root of that y denominator. Okay, so we have that it's vertical. A squared is 25, which means a equals 5. Okay, so since this is vertical, I have to go up and down by 5 from my center point. All right, so I'm going to do my vertices in blue here. 1, 2, 3, 4, 5. And then down 1, 2, 3, 4, 5. Okay, so pause the video, try and come up with those 2 coordinates. All right, so you guys should have gotten -1, 7, and -1, -3. All right, next is the foci. I'm going to do this in, let's go purple. All right, so your foci, the equation is different here. It's c squared equals a squared plus b squared now. Okay, so I'm going to go down and do this below the box here. So c squared equals a squared plus b squared, or you could think of it as just add your 2 denominators. So 25 and 36. Okay, those add to 61. So c squared equals 61. Square root both sides. C equals radical 61, which is approximately 7.8. Okay, and that 7.8 is going to help me graph it. All right, but very similar to ellipses, your foci are in the same direction as your vertices. So since we went up and down for vertices from the center, I'm going to go up and down by 7.8 for my foci now. So I'm going to plot them on the graph. You should pause the video and do the same. Okay, so you should have gotten -1, 2 plus or minus radical 61. Okay, you could have also said -1, 9.8, and -1, -5.8 if you use the numerical value. All right, one thing I want to point out to you guys, the foci are further from the center than the vertices. That's a little different from ellipses where the vertices were further away. And that's just because it's a plus. C squared equals A squared plus B squared. So now C is always the largest of the three, A, B, and C. All right, so the last thing, you guys are almost done here, equations of the asymptotes. Okay, so your asymptotes, I'm going to go back up to that first page. Y minus K equals plus or minus M times X minus H. Okay, the Y minus K part and the X minus H are very simple. I'm going to do this in red. It's literally just your numerators without the squared. So Y minus K, Y minus 2 equals plus or minus, I'm going to leave it blank right now until we go over the slope, and that's times X minus H, which just comes from your X numerator, which was X plus 1. All right, now your slope. Okay, so point slope form, y minus y1 equals m times x minus x1. You fill in one point that you know is on the line, which we used basically -1, +2, which that point is the center point, which is shared by both asymptotes. Okay, so both asymptotes are going to cross at that center point. But now we got to figure out the slope, and the method that you use is to draw a box. Okay, so I have that a equals 5, that was under y, and b, square root of 36 is 6. So you're going to make a box by going from your center point up and down 5. We already did that for the two vertices. And now right and left by 6. So 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. Okay, and then doing the same from the bottom there, I'm going to make a box connecting those 4 points. All right, now this box is not actually part of your graph. It just helps you to graph it. That's why I use dashed lines. And now your asymptotes go corner to corner through the centerpiece. All right, and asymptotes are always dashed lines. So corner to corner through the center point. Okay, so those are my two slant asymptotes. And the reason I do that is it helps me to create the shape of the graph. You're almost done. Now we're ready to actually draw our two curves. Your curves start at your vertices. Okay, so start at one of your vertexes or your vertices and approach your asymptotes without actually touching them. Okay, since this is vertical, you notice your hyperbola opens up and down. All right, guys, so take this time to pause and copy any of these notes that you missed. I don't expect us to be experts at it just yet. We're going to practice this all in class tomorrow and probably the day after that. All right, thanks for listening. See you guys tomorrow.